This is just meant to be a very short video on an optional topic that is not part of our course. You're not responsible for this, but I get a lot of questions about it, so I just want to briefly address this issue. It's a rational function that is not reduced. So here's the exercise. Suppose we want to graph f of x equals x plus 3 over x squared plus 3x. So that's a fractional form that is not reduced. If you look at the line here below here, x plus 3 over x squared plus 3, I can factor the denominator, I can factor out an x, and I can cancel a factor of x plus 3 above and below. And in algebra, you're used to reducing this and saying it reduces to 1 over x. And they basically are almost equivalent forms. There's a slight technical difference that I wouldn't worry too much about in life. But so the graph of f has a vertical asymptote at x equals 0, the y-axis, but not at x equals negative 3. And I say that because we're used to setting a denominator equal to 0 to find the vertical asymptotes. That only works if you have the reduced form. So if a fraction can be reduced, it's got to be reduced first before you look for vertical asymptotes. So again, here I say this is because we were able to cancel the factor of x plus 3. So the graph of f is almost identical to the graph of g of x here that I call 1 over x. I'm just using the letter g, so I don't want to use the same letter for two different functions in this video. So this is just y equals 1 over x that we're very familiar with. So there's one small difference. The domain of f is determined before any factors are canceled. Thus, the domain of f does not include x equals 0 and x equals negative 3. In interval notation, here's the domain showing those two numbers removed. That just means all real numbers except 0, negative 3. The domain of g is, as indicated, that's all real numbers except 0. So they're technically different because their domains are different. G is defined at negative 3. F is not defined at negative 3 because we have to base the domain on the original expression, not the reduced expression. The graph of f is like the graph of g, except that there is a hole at the point corresponding to x equals negative 3. And here are two graphs. And so just notice the difference. Again, we're not going to have examples like this in our course, but you may see them elsewhere. Here's good old g of x equals 1 over x, a graph we spent a lot of time on. Here's the graph of f. It looks almost identical, but there's a hole at that one point because in the original expression, we cannot, if we try to plug in x equals negative 3, we get an undefined fraction. We're trying to divide by 0. So that division by 0 possibility forces us to cut out a hole, leave that one point missing from the graph of f. And that's that.